have you ever stopped and really wondered what's going on inside your computer or your phone? It honestly feels like magic, right? But believe it or not, it all starts with a simple piece of silicon. So today, we're going to trace that incredible journey all the way from a basic chip to a window on the entire world.
Everything kicks off with this one simple action. You push a button, a little light flickers on, and just a moment later, your whole digital life is right there on the screen. But that single press unleashes this incredibly complex, super fascinating chain of events. So what exactly is this machine that we're waking up?
Well, when you boil it all down, this is what a computer is. It's a machine that's designed to do two things really, really well: store data and process that data by doing calculations. You can almost think of it as a super-powered calculator that's just amazing at handling information. And every single computer, from a giant supercomputer to the smartphone in your hand, works on one fundamental principle.
And that's the relationship between hardware and software. The hardware is all the physical stuff you can actually hold and touch. The screen, the keyboard, the little chips inside. And the software? That's the intangible set of instructions, kind of like the ghost in the machine, that tells all that physical hardware exactly what to do. You just can't have one without the other.
Okay, so let's start with the body. We're going to metaphorically pop open the case and take a look at the essential parts that make up the physical computer. The very first thing you'd probably notice is the motherboard. And really, it's the backbone of the entire system. Think of it like a central nervous system. It's this giant circuit board that everything, the brain, the memory, the storage, plugs right into. It's the thing that lets all the different components talk to one another.
And sitting right there, in the heart of the motherboard, is the CPU, the central processing unit. This is without a doubt the brain of the whole operation. Every single click you make, every letter you type, it all gets processed right here. This thing is constantly performing millions, sometimes even billions of calculations every single second, just executing the software's instructions.
Now, for the brain to work that fast, it needs a place to think, right? A workspace. And that's where RAM comes in. RAM is the computer's short-term memory. Whenever you open a program or a file, it gets loaded into RAM, so the CPU can access it super quickly. It's like the top of your desk. It's where you keep everything you're currently working on. And that's exactly why having more RAM lets you multitask and keep a million browser tabs open without your computer grinding to a halt.
But what about all the stuff you're not actively working on? Well, that all goes into the hard drive. This is the computer's long-term memory. It's your digital filing cabinet where all your photos, your documents, and your applications are stored nice and safe, even when you turn the power off.
So, this distinction is absolutely crucial. RAM is what we call volatile memory, which is just a fancy way of saying if you turn off the power, poof, it's wiped clean. The hard drive, on the other hand, is non-volatile, so it remembers everything. And that is why you always have to save your work. You're literally moving it from the temporary desk, the RAM, to the permanent filing cabinet, the hard drive.
And that filing cabinet of yours comes in two main flavors. You've got the traditional hard disk drive, or HDD, which uses a physical spinning platter and a little mechanical arm, almost like a tiny record player. And then there's the modern solid-state drive, or SSD, which uses memory chips with zero moving parts. And because there's nothing moving, it's way, way faster and a lot more durable.
Okay, so we've got all our physical parts connected to the motherboard. Let's go back to that power button. How do all these lifeless components go from just sitting there to becoming a fully functioning machine? It's a process called booting, and it happens in a few lightning-fast steps. First, something called POST, the power-on self-test, does a quick check to make sure all your hardware is connected and working. Then, the BIOS, which is the most basic software living on the motherboard, wakes up all that hardware. Next, a tiny program called the bootloader finds your operating system on the hard drive. And finally, the core of that OS, called the kernel, gets loaded into RAM, and from that moment on, the operating system is in full control. So, the hardware is awake, the core system is running, now it's time for the software to really shine. This is that intangible layer, the ghost in the machine, that actually makes the computer useful to us. Generally, software gets split into two big categories. You've got system software, which is the foundational stuff that just keeps the computer running. Your operating system, for example, like Windows or Mac OS. And then you have application software, which is basically everything else you install to get specific things done, like your web browser, a video game, or a text editor. The operating system, or OS, is the real big boss here. It's the master manager for absolutely everything.
It juggles which programs get to use the CPU. It allocates memory and RAM. It organizes all your files on the hard drive. And, importantly, it gives you that visual interface, your desktop and your icons, that lets you actually use the machine without knowing a single line of code.
And running on top of that OS are our applications. Each app is really just a program built to do a specific job. So if you're listening to music or editing a photo or browsing the web, you're directly using an application. And that application is relying on the OS to talk to all the hardware for it. So what are these applications creating and using all the time? Files. A file is just the basic way we store data. It's a named collection of information, and that information could be anything: a Word document, a picture, a song, or even the application program itself.
All right, we now have a fully functional computer. Hardware and software are working together beautifully. But the real magic, especially today, happens when we connect that single machine to billions of others.
Now, the internet didn't just pop into existence. It actually started back in the 1960s as a US government project called ARPANET. Over the next couple of decades, it started to grow and become commercial, and it eventually turned into the worldwide system that, let's be honest, we can't imagine living without today. And that's the real key to understanding it. The internet isn't one single thing in one place. It's actually a network of networks, this massive global web made up of countless smaller networks from businesses, governments, and universities, all speaking the same digital language so they can share information. Now, to talk to each other on this giant network, every single device needs an address. That's its IP address. Just think of it like a unique mailing address for your computer. It's how little packets of data know exactly where to go, whether they're traveling across the room or across the entire planet. But of course, we don't go around trying to memorize long strings of numbers. That would be impossible. And that's where DNS, the domain name system, comes to the rescue. It basically acts as the internet's phone book. When you type an easy-to-remember website name into your browser, DNS is what looks it up and translates it into the numerical IP address that computers actually understand.
And that really brings us full circle. Think about it. We started with the physical hardware, the CPU, the RAM. Then we built layers of software on top of that, the BIOS, the OS, our applications. And then we connected all of that to a global network using even more layers, like IP addresses and DNS. Each new layer simplifies the one below it, taking this incredibly complex system and making it simple enough for all of us to use every single day.
From a simple push of a button to an entire universe of information, it is a truly amazing process. So as we wrap this up, think about that whole journey. From the boot process that first wakes the machine up, to the DNS system that connects you to a website on the other side of the world. Which part of this hidden world seems the most incredible to you?